Hello friends, welcome to Silicon VLSI. Today we will discuss about well proximity effect. We call as a WPE also. So let's start. What is well proximity effect? We can say as a WPE also. WPE is a layout dependent effect that affect the transistor performance. It occurs due to the proximity of transistor to the well edge, N well or P well. More prominent in deep submicron technology. It means it is dominant in 65 and below technology node. So WPE generally we can say it is a layout dependent effect. Why WPE occur? So mainly WPE occur during the fabrication, halo doping and when implantation are non-uniform near the well edge. This cause variation in threshold voltage and mobility. The closer a device is to the well edge, the more its effect. It means, let's see in diagram, what is the well proximity effect. So if you see this vertical black line, arrow mark is there, it is ion implantation. And this is the opening. So during a fabrication process, ion implant occur like this. So in definition, sum of ion which is near the well edge. It means this is the well edge here and here. So this whatever ion implantation is, it is hitting, some of ion is hitting near the well edge. So what happen is whatever ion hitting here, it will scatter somewhere in this region. In this region as well. So the ion implantation, rate of ion implantation in this region is more as compared to this. In this region, ion implantation is uniform. But if you see in this region, ion implantation is more, or we can say it is vary because of scattering. It's happened because of the well edge. So what happen is in this region, if you put any device in this region, in this location, VT will be different as compared to this device. So ideally what WPE says that any device we should not put near the well edge. So that's the reason if you observe in lower technology node, PMOS or NMOS, we are keeping far away from the well region. There is some rules like we should not keep any OD near to the well edge because of this well proximity effect. So this is the main reason of the well proximity effect. Ion is scattering near the well edge. So because of that, VT is vary, or we can say the VT is increased, or sorry, VT is decreasing in this region. On the circuit design, it will increase the threshold voltage. It will also impact drive current variation, timing variation in digital circuit, degradation in analog circuit performance, gain, offset, etc. So WP, how it is impact in analog as well as digital. So in digital it can tolerate in some extent. Ideally it should not. Like we should not keep any device near the well edge. In digital also. But in some extent it can be tolerated. But in analog it is very sensitive device. Maybe lead to performance failure, yield loss. So we cannot ignore this effect in analog circuit. Some techniques are there to avoid the well proximity effect. First and most important thing is we should not keep any device near the well edge. We should keep in some minimum distance. This is the main important thing. Second one is a dummy device. As we are placing in analog device to better surety, like well proximity effect is not impact on the main core device. So that's the reason we are putting the dummy device in the analog circuit. Dummy device is also used for other part like density violation, but it is also used for WP effect also. So use of guarding also, this is also helping to avoid the well proximity effect. So basically our main aim, any device should not put near the well edge. we should put far from the village. That is the main concept of the WP effect. In interview may ask you like, if I keep any device far from the village, I can say that there is a zero WP effect. At that time you should answer like, we cannot say it is zero because still we do not have a guarantee some iron is scattered here on this location. We cannot say, but as compared to this device has a less WP effect. You should not say that I, with the help of this, we are avoiding 100% WP, because there might be some variation in this location also. So we cannot say it is 100% proof, like it is 100% WP less. So ideally WP is a critical layout dependent effect, impact on transistor behavior. Proper pacing and layout technique can minimize its impact. Main thing is we should not keep any device near the village. Second thing is we have to put the dummy device around it. Third thing is analog layout is we have to put the guard ring. Important in advanced process node, especially in analog and RF. This effect is dominant in analog as well as RF design. So that is the we call as a WP effect. If you like this video, this information, please share and subscribe. Thank you so much.